Basic formula and principles in electricity. Resistance, the property of the material that opposes or restricts the flow of current through the conductor, is called resistance. The unit of electrical resistance is ohm. For the formula, R is equals rho times L divided by A. Or R is equals rho times V divided by A squared. Or R is equals rho times L squared divided by V. Where R equals resistance in ohm, A equals cross-sectional area in square meter, rho equals resistivity in ohm meter, L equals length in meter, V equals volume in cubic meter. Atom is the smallest part that of an element can be reduced to and still keeping the properties of the element. Parts of an atom. Proton, positively charged, is equal to 1.672 times 10 to negative 27 kilograms. Electron, negatively charged, which is equal to 9.107 times 10 to negative 31 kilograms. Neutron, no charge and equal to 1.672 times 10 to negative 27 kilograms. Structure of an atom. Nucleus of an atom or center of an atom. It is where the protons and the neutrons are located. The electron revolve around in orbits or shells around the nucleus. N equals 2n squared. Where n equals total number of electrons on a given shell. N is the nth shell of the atom. Matter is anything that occupies space and has weight. Element is a substance that cannot be decomposed any further by chemical action. Molecule is the smallest particle that a compound can be reduced to before it breaks down into its elements. Valence electrons is the electrons found in the outermost shell or orbit of an atom. Atomic number represents the number of electrons or protons of an atom. Atomic mass represents the sum of protons and neutrons of an atom. Tables of element, number of electrons, number of protons, number of neutrons and valence electrons. Copper element, number of electrons 29, number of protons 29, number of neutrons 34 and valence electrons 1. Aluminum element, number of electrons 13, number of protons 13, number of neutrons 14 and valence electrons 3. Germanium element, number of electrons 32, number of protons 32, number of neutrons 41 and valence electrons 4. Electric charge. Coulomb is a unit of electric charge, which equivalent to 6.25 times 10 raised to 18 electrons or protons. Potential difference. Volt, a unit of potential difference, equal to 1 joule of work done per 1 coulomb of charge. Or 1 volt equals 1 joule divided by 1 coulomb. Ampere, a unit of charge flow equal to 1 coulomb of charge past a given point in 1 second. Or 1 ampere equals 1 coulomb divided by 1 second. Specific resistance, resistivity, a resistance offered by a unit cube of the material. Circular mil is the area of a circle having a diameter of 1 mil. Circular mil equivalent, cm equals diameter squared. Or 1000 mil equals 1 inch. Or 1 mcm equals 1000 cm. Effect of temperature in resistance. The resistance of the wires increases as the temperature increases. For the formula, R sub 1 over R sub 2 equals T plus T sub 1 over T plus T sub 2. Or, R sub 2 over R sub 1 equals 1 plus alpha T sub 1 times delta T. Or, alpha T sub 1 equals 1 divided by T plus T sub 1. Or, delta T equals T sub 2 minus T sub 1. Where, R sub 1 equals initial resistance in ohm. R sub 2 equals final resistance in ohm. T equals inferred absolute temperature, or temperature when resistance of a given material is 0. T sub 1 equals initial temperature. T sub 2 equals final temperature. Delta T equals change in temperature. Alpha symbolizes temperature coefficient of resistance or ohmic change per degree per ohm at some specified temperature. Tables of material with specified resistivity over length and temperature and coefficient of resistance at 20 degrees. Silver with resistivity of 9.9, temperature of 243 degrees C and coefficient of resistance 0.0038. Copper with resistivity of 10.37, temperature of 234.5 degrees C and coefficient of resistance 0.00393. Aluminum with resistivity of 17, temperature of 236 degrees C and coefficient of resistance 0.0039. Tungsten with resistivity of 33, temperature of 202 degrees C and coefficient of resistance 0.0045. Zinc, with resistivity of 36, temperature of 250 degrees C and coefficient of resistance 0.0037. Insulation resistance of cables. Formula, R equals P over 2 phi L times ln R sub 2 over R sub 1. Where ρ is the resistivity of the insulating material in ohm meter. L equals length of cable in meter. R sub 1 equals radius of the cable. R sub 2 equals radius to the outer surface of the insulation. Conductance is a measure of the material's ability to conduct electric current. It is equal to the reciprocal of resistance. Siemens, formerly mho, is a unit of conductance. Conductance formula, G equals 1 divided by R. Or G equals sigma times A divided by L. Or sigma equals 1 divided by rho. Where sigma equals conductivity in Siemens per meter. L is length in meter. A is the cross-sectional area in square meter. Rho is the specific resistance in ohm meter. G is the conductance in Siemens. R is the resistance in ohm. Thanks for watching. Subscribe, like and share.